Morning, students. Let's continue the topic linear methods, feature constructions of linear methods, Unit 3. Linear method in reinforcement learning. What are the linear methods we are implemented in the reinforcement learning? Means already we talked about that algorithm, that stochastic gradient and semi gradient in reinforcement learning, that implement the features of construction in linear methods. So a linear method is a one part of S, R, S, A, R, and P. The state, action, reward, transition, the four probabilities, premises to methods to involve in the linear method. So linear method is first type of the linear method is temporal difference of error. I already told you that temporal reference of error means is 0. So the TDE is nothing but 0. So temporal difference is 0. What are the premises we have done in that linear method? Means W premises to W plus alpha till not ST. S is state, T is transition. So S state and transitions is converted the premises to the W and alpha till. And then what are the sequence of linear equations and linear methods? SARSA, the W implement of W plus alpha del naught ST comma AT. So state transition and action transition, the premises to the W, the alpha del naught equivalent to the ST comma AT. So S is a premises of state, action, reward, state, action. Is going the process to implement it in temporal difference of error 0. The next one is Q learning. Q learning linear method to implement as it is same method. Transition of S and transition of A to the implement of W. The del is to delete. The alpha is to delete to the del premises. The Q learning, we have to implement that Q of ST comma AT. So the Q of ST comma AT, the future construction of linear method. To the find out these comes under the premises to all the find out the feature construction to the linear method. The last one, SLTD. What is it? Least squares temporal difference. So least square temporal difference means the least one of the method to cultivate, to convert it into the TB. Okay, wow. So the TB is a minus 1. Minus 1 is called as least squares. So least square to add of the delete alpha and del to add the W, the premises of ST comma AT. So ST comma AT will added to the least square. So ST and AT will square root of the least square temporal difference. So LSTD to premises of W equivalent to not T by naught. So minus 1 not T. B is absence of the feature of construction of linear method. So the next topic is, we'll continue the feature construction, how to implement and what are the rules and what are the processes of implemented to that linear method. The feature construction of linear method, first one is tidal coding. See, students, the tidal coding will come the VStudio coding. So we will see this coding and all in the classroom itself. Why I didn't show the coding means it's coming by the overlapping brain. So what are the I will explain the tidal coding. What is the tidal coding and how to the things or the represent to the tidal coding. So tidal coding is divides the state space into multiple overlapping grains title, each within own set of titles. So each state is represented by the set of titles and falls into the across all the titles. So title coding is nothing but state space. The set of title is nothing but they represent as a set of title. That means tiding. We have see the code in next class. We see the coding. Okay. So radial basis function RBF, the Grandson function, the loss of function we saw that no, that the center of the different point will called as a RBF is nothing but the RBF, and they represent what are the similarities to state to these the center point. What are the center point? By IS. S is a state. So S is a experience minus 2 lambda 2 by S minus CI2. The polynomial basis function means a construction feature based on polynomial combination of the state variable of S1, S2 and Sn. This will comes under into the polynomial base function, and polynomial is a RP functions a center point of the function. Okay, next for base function means combinations of sine and cosine functions to represent the state space. So sine theta, the cos theta, all under will comes under the linear method. You don't confuse about this. The combinations, what are the combination sines and cos thetas a function to represent the space, state space that we are implemented to the one by one. Each by different points we have to implement the coding. Okay, so the title coding will represent the title of set of title, and RBF is nothing but they represent the center of point to the different state space. State space we have to find out the center point. Polymer BBF is nothing but the construct the center point to the state values, state variables. That means S1, S2 and Sn. And the combinations of sine and cosine function they represent the FBN function. So these are under feature construction and linear methods to implemented in the functions. So okay, the third unit is completed. So next fourth unit we will continue to tomorrow classes. Thank you.